Using the equation below, calculate the mass in grams of ammonia formed from reacting 64 grams of nitrogen. And we've been given the relative atomic mass of nitrogen as 14 and hydrogen as 1. So if we have a look at the equation here, this is the Haber process. This is the process of reacting hydrogen and nitrogen together to form ammonia. We can see that it's balanced. So we've got 6 hydrogens on the reactant side and 6 on the product side, 2 nitrogens on the product side and 2 nitrogens on the reactant side. So the first equation that we need to be able to use, or the main one in this question, is that the number of moles equals the mass over the relative formula mass. So number of moles equals the mass over the relative formula mass, MR. So if we have a look here, we've been told that we're reacting 64 grams of nitrogen. And we know the atomic mass, or the relative atomic mass of nitrogen as 14. So we can work out the number of moles of nitrogen. So if we have a look, the atomic mass of nitrogen is 14. But in this formula we have N2, remember nitrogen goes around as a pair, so that means the molecular mass of nitrogen is 28. So the number of moles of nitrogen is going to equal the mass of 64 divided by 28. And if you put this into your calculator, you do 64 divided by 28, you'll get 2.285 approximately. So now we know that there are 2.285 moles of nitrogen reacting. And if we have a look at our balanced equation now, what we can see is that for every mole of nitrogen that reacts, 2 moles of ammonia are formed. So that means if 2.285 moles of nitrogen are reacting, that means we need to have double that number of moles of ammonia formed. So if we want to know the mass of ammonia that's formed, we need to rearrange this equation. So then to rearrange it, we can use our triangle, where moles equals mass. I'm just going to put that as grams over the molecular mass. We want the mass, so that means the mass is equal to the number of moles times the molecular mass. So the number of moles is this times 2, and the molecular mass is N, which is 14, plus H times 3, and H is 1, so 3 there, which is equal to 17. So it will be 2.285 times 2 times 17. And if you put that into your calculator, you will get a mass of 77.7 grams, which is the final answer.